Hello there, sunshines. Today we're going to talk about perpendicular bisectors and angle bisectors. I know, it's so fun! But let's talk about what a perpendicular bisector is first. This is going to be a line. I realized I didn't give you the definition of this. A segment, a ray, that divides a segment into two equal parts and is perpendicular to the segment. Okay, so a perpendicular bisector, it's a line, a segment, or a ray that divides a segment into two equal parts and is perpendicular to the segment. Okay, so again, in order for it to be perpendicular, we need to either see the little box in the corner, or they need to tell us it's a perpendicular bisector, or they need to tell us that an angle is 90 degrees. Okay, please, excuse me, please don't go by looks. All right, so if we're looking up here, this perpendicular bisector theorem, it says if a point lies on the perpendicular bisector of a segment, then is equidistant from the endpoints of the segment. All right, what the heck are they talking about? All right, so first of all, this line right here, CD, this is our perpendicular bisector. It's perpendicular to AB because of the little box, and AD is going to be congruent to DB. So let's start with that. All right, so here it says if CD is perpendicular to AB, and AD equals DB or BD, then here's our point C, then AC is going to be the same distance as BC. Okay, so AC is going to be congruent to CB. So these sides are going to be congruent. Okay, if it's a perpendicular bisector and you have a point on that bisector. So if a point lies on the perpendicular bisector, which is point C, then it is distant, okay, so the same distance from the endpoints of the segment. Here's our endpoints of the segment, so that means those two sides are going to be congruent. All right, the converse. Now remember, we talked about the converse, so we can flip it around. If a point is equidistant from the endpoints of a segment, then it is perpendicular to the segment. So here we know that, here's our endpoints. This is a point. Because it's equidistance from these 2 points, then we know that this is going to be perpendicular, and we're going to know that AD is congruent to DB. So then we know that line CD is going to be perpendicular to segment AB, and we know that AD is congruent to DB. Okay, so it goes backwards. All right, so let's do some of these. It'll make a little more sense. All right, here we know that this is a perpendicular bisector. All right, we know it, oh my gosh, we know it because of the little box and because of those 2 tick marks. All right, which means that this point up here is going to be equidistant to these endpoints, which means in my long wordiness, those sides are going to be congruent. So we're going to set those equal to each other. So we got 7x plus 24 equals 13x minus 48. Where in the heck did 14 come from? How about 48? Okay, I'm going to subtract my 7, so I get 6x. I'm going to add my 48 and get 72. Divide by 6, x is going to be 12. Okay, again, just find the value of x, so we're done. That's it. All right, number 2. We know that this is perpendicular. We know that that thing is perpendicular. We know these angly sides are congruent, which forces these pieces to be congruent. So we're going to set them equal to each other again. So we're going to have 17x minus 3 equals 9x plus 13. We're going to subtract our 9x, get 8x, add our 3 to get 16. X is going to be 2, dividing by 8. I don't know my numbers today. And again, we're done. Find the value of x. All done. All right. For these next next 4, we do need to plug it in. All right, so number 3. Okay, come on. Number 3, it's perpendicular. These pieces are congruent, which means that these sides are going to be congruent. So you're going to have 7x minus 22 equals 4x plus 5. Subtract your 4x, so we get 3x. Add your 22, so we get 27. X equals 9. Our s is the 4x. So our s is 4 times 9 plus 5, which gives us 41. So 4 times 9 is 36. 36 plus 5 is 41. All right, why don't you pause the video and try 4, 5, and 6 by yourself. So pause the video, come back when you're done to check your answers. All right, because DE is congruent to DF, EG is going to be congruent to FG, so we're going to have 4x minus, that's a 14x, minus 37 equals 2x plus 11. Subtract your 2x, so you get 12x. Add your 37, so you get 48. X equals, not 24, holy camole, equals 4. EG. EG is our 2x plus 11, so we're going to take 2 times 4 plus 11, which gives us 19. All right, number 5. Okay, AC is congruent to CB, which means AD is congruent to DB. So we're going to have 5x minus 11 equals 3x plus 17. Subtract our 3x, so we get 2x. Add our 11, so we get 28. X is 14. And now we need AB. Ooh, AB is that whole thing, so we want to plug it into both and add them together. So AB, we're going to take 5 times 14 minus 11 plus 3 times 14 plus 17, which gives us 118. Okay, because we needed AB, which is that whole thing. So you got to plug it in and add it to this one when you plug it in. All right, JK is what we're looking for. Since it's perpendicular, these two pieces are congruent. JK is going to be congruent to KL. So you're going to have 6x minus 26 equals 3x plus 34. So we're going to get 3x. Add that, we get 60. X is going to be 20. JK, plug it in. That's an X, a sloppy X. So we're going to have 6 times 20 minus 26, which gives us 94. All right. Number 7. Oh no, look at this. they give us coordinate points. That's not nice. All right, so we've got triangle JKL. JKL. If JK is formed by J at -7, -8, so this is going to be at -7, -8 on the coordinate plane. K is at 1, 4. Now we need to determine if L lies on the perpendicular bisector of JK. So we want to know if this is our L, and that's going to be at -2, -9, 2. Holy camole, this is like craziness. I drew my picture wrong. This shouldn't be like this. It should be like this. I was right the first time. Okay. So we need to find the distance of JL, and we need to find the distance of KL. All right? Because if they're the same, if this distance here is the same as this distance, then L is on that perpendicular bisector. All right, so we're going to do KL first. So the distance is going to equal KL, 2 minus 4 squared plus -9 minus 1 squared. So what does that equal? So that's -2. -2 squared is 4. That's -10. That's plus 100. So that's going to be the square root of 104. And I'm just going to leave it like that for now. Then we need to do JL. The distance for JL. So 2 plus 8. So it's 2 minus a negative, so 2 plus 8 squared plus -9 plus a -7. No, minus a -7 makes it plus 7. So now we got 100 plus 4. Okay. So since those are congruent, yes, point L is on the perpendicular bisector. How about a B instead of a P? Oh my gosh, I can't write today. That's perpendicular, remember. All right, some angle bisectors, okay? Remember, angle bisectors are segments or rays that get cut angles in half. So if a point is on an angle bisector of an angle, then the point is equidistant from the sides of the angles. What the heck are they talking about? So if AD bisects ABAC and AB is perpendicular to BD, AB perpendicular to BD, and AC perpendicular to CD, then we know that BD is going to be congruent. So this piece here is going to be congruent to DC. Okay, so this time it's an angle bisector. These little pieces down here are perpendicular from the angle bisector to the sides. If that's the case, then those little pieces are congruent. Okay, so now we can say the whole other thing. If we know that BD is congruent to CD and these two sides are perpendicular, then we know that AD bisects angle BAC. Okay, and so we'll know that angle, where to write this, that angle BAD will be congruent to angle DAC. Okay, so these little angles here will be congruent. if we know all that other stuff. And you can't see what I'm writing. Holy camole. I apologize. Okay, so it just goes back and forth. All right, here we know this is an angle bisector because these little angles are congruent. This piece here is perpendicular to that side. This piece here is perpendicular, which means that these pieces will be congruent. So we're going to have 9x minus 5 equals 4x plus 30. Subtract your 4, so you get 5x. Add your 5, you get 35. Holy cow, I can't write 5. So x is going to be 7. Okay, and find the value of x. So we're done. We did that. All right, number 9. Find the value of x. Since these pieces are perpendicular and they're congruent, then we know these angles are going to be congruent. So 8x minus 41 equals 5x minus 11. Subtract our 5x, so we get 3x. Add our 41, so we get 30. Divide by 3, x is 10. And it just said find the value of x, so we're done. We like those. All right, number 10. Why don't you try 10 and 11? This time you will have to plug them in, but go ahead, try 10 and 11. Pause the video and come back and then just check your answers. All right, so 10, I'm going to do 13x minus 4, 8x plus 11. Subtract our 8, so we get 5x, add, we get 15, x equals 3. AD is what we're looking for, so we're going to take 13 times 3 minus 4, so this is 39. 39 minus 4 is 35. So that's our final answer. All right. Since this is perpendicular and congruent, we can set those equal to each other. So we're going to have 8x minus 32 equals 3x plus 3. So we get 5x equals 35. X equals 7. And wxz. So we start at x down to w out to z. So just this one. So the measure of angle xwz equals 8 times 7 minus 32. 8 times 7 is 56. 56 minus 32 is 24 degrees. All right, number 12. This looks a little different, doesn't it? But it's the same thing. It's just a little bigger. All right, so here's your perpendicular and congruent sides. Okay, that's what these were. So this angle here is like your z here. So coming down, that means these angles are going to be congruent, and you set those equal to each other. So we're going to have 5x minus 37 equals 2x plus 20. Excuse me. Subtract your 2, so we get 3x. Add our 37, we get 57. X equals 19. And now we need FGH. Okay, so we're looking for this. We start at F, come down to G, out to H. So we're looking for that whole big angle, which means we need to add those two together. So we're going to take the measure of angle FGH is going to equal 2 times 19 plus 20 plus 5 times 19 minus 37. And when you do all that, you should get 116 degrees. Fun stuff, isn't it? I told you. Told you. All right, your homework tonight is homework 5.2, perpendicular and angle bisectors. It's very similar to what we did in class. Okay, 7 looks a little tricky. We'll come back to that. All right, so what does it say back here? 8 and 9 determine. Okay, so we did those, and yeah, you can do all those, but let's look at number 7. All right, if QT is perpendicular to PR, find each measure. Okay, well, you know that these two are congruent, okay, because they tell you this is perpendicular to PR. These have your y's, so these are going to be congruent. So set those equal to each other. And once you have your x and once you have your y, you can plug them in here to find out how long PT is. Multiply that number by 2 to get PR. It's not that scary looking. You got this. I know you do. All right, that's it for today. Have a wonderful day.